If you look at inductor characteristics in datasheets, for example from Coilcraft, the first thing you encounter is the DC bias effect. A DC current component generates magnetic flux in the core and shifts the operating point. As a result, the AC component can no longer vary over the same range as it could without biasing. Previously, the flux swing could extend from saturation to saturation. With DC bias applied, that usable range becomes narrower. This directly affects the inductance value. Another important point is that different core materials behave differently. Datasheet curves typically show two distinct behaviors: hard saturation and soft saturation. In the case of hard saturation, inductance drops rapidly as the DC bias current increases. In practice, the inductance effectively collapses. With soft saturation, the inductance decreases more gradually. This behavior is determined by the core material itself. Ferrite cores typically exhibit harder saturation characteristics, while powdered core materials tend to saturate more softly. This property is directly related to the magnetization curve. As the operating point shifts, the magnetic properties change as well, and therefore the behavior of the inductor in the actual circuit changes too.